We want to give credible information about nuclear power. To start, I'd like to clarify some terminology that has been used inaccurately in some media reports. I'd also like to discuss the safety profile of nuclear power. We support the brave reporters in Ukraine and journalists who seem to be working around the clock in the US and elsewhere, and perhaps some of this information can be helpful. At every nuclear power plant, there is an electrical switchyard. The power generated at the plant goes out to the electric grid through the switchyard. And the switchyard also brings in power from the electric grid to power systems on the nuclear power plant site. A loss of offsite power, or loop, occurs when the electric power to a nuclear plant from the outside electric grid is lost. In the event of a loop, the plant's generators, or emergency diesel generators, can provide power to ensure the plant operates safely. A station blackout, or SBO, is when all on-site power sources are lost during a loss of off-site power event. That is, the on-site emergency power sources are not available. This is what happened at the Fukushima plant in Japan after the tsunami disabled the emergency diesel generators and washed away their fuel tanks. A new approach called FLEX keeps nuclear power plants operating safely even in the event of a station blackout. FLEX refers to a series of diverse and flexible mitigation strategies that can be employed to ensure emergency power supplies to a nuclear plant in the event of a beyond design basis accident, such as station blackout. In the United States, there are 2 FLEX locations in Phoenix, Arizona, and Memphis, Tennessee. Each of these locations includes multiple sets of everything needed, including portable backup generators, pressure pumps, diesel fuel tanks, water treatment, and other equipment, all ready to be moved to any US nuclear power plant using air and ground transport. Since Fukushima, other countries have also implemented FLEX-type approaches. A loss of coolant accident, or LOCA, can occur with a break in the reactor coolant system. This stops the water from circulating in the core, resulting in the fuel rods heating up and possibly boiling the water to steam. As the fuel rods heat up, steam-zirconium interaction can occur. This means that the oxygen from the water, H2O, can join with the zirconium cladding of the fuel rods, releasing hydrogen into the environment. As hydrogen is flammable, its buildup in the reactor or power plant can represent a significant explosion hazard if not addressed. Such an explosion can release radioactive material into the environment. That's what happened at Fukushima, hydrogen gas explosions, not nuclear explosions. Because of the advances in nuclear technology since Chernobyl in 1986, none of the workers at the Fukushima plant were hurt that day in 2011. The nuclear power industry has made tremendous strides in improving the safety of reactors and the structures that house them. Some of these improvements include hydrogen recombiners that remove hydrogen and venting systems that can remove hydrogen. At Lightbridge, we are adding technological advancements. We have reimagined the light water nuclear fuel rod for the first time in decades to enhance safety even more and bring additional advantages to nuclear power. Lightbridge fuel are much more advanced technology than current fuel used in reactors and can be retrofitted into the current large reactors without any changes to the reactors. We are also developing our fuel to run in small modular reactors under development, which we believe have a bright future in global markets. Current fuel rods have small pellets of uranium oxide stacked up inside a tube. Our fuel rods consist of solid metal in several zones with different materials, produced in an advanced manufacturing process that we invented. Lightbridge fuel runs about 1,000 degrees Celsius or 1,800 degrees Fahrenheit cooler in the reactor than current fuels, which results in some of the safety advantages our fuel brings to a reactor. In a loss of coolant accident within the design basis of the plant, Lightbridge fuel rods will not reach high enough temperatures to have significant steam-zirconium interaction, so there will not be excess free-floating hydrogen or a hydrogen explosion. Current nuclear fuel is highly proliferation resistant, very difficult to use for nuclear weapons purposes. Lightbridge fuel has been independently validated in a leading peer-reviewed nuclear technology journal to be the most proliferation-proof nuclear fuel there is. Lightbridge's spent fuel is not suitable to would-be proliferators to make nuclear bombs. The nuclear power industry did not create the stockpiles of weapons-grade plutonium that governments possess, with the United States and Russia holding the largest quantities. Governments created that plutonium in research reactors. But the nuclear power industry has the capacity to eliminate that plutonium in fuel rods for power reactors to create electricity. Lightbridge fuel can be used to eliminate plutonium 5 times faster than other technology. Zero carbon nuclear power competes with natural gas, coal, and renewables. There is no other nuclear fuel in existence or in development that could bring to current reactors the economic benefits that Lightbridge fuel will provide. In addition to the safety advantages, our fuel will increase the power output and run longer in the reactors, increasing revenue from electricity sales. Lightbridge fuel can be used to increase and decrease power in a reactor more quickly than current fuels, so reactors could load follow in an electric grid with lots of renewables, increasing and decreasing in power output as the sun shines or the wind blows on a zero-carbon electric grid. Lightbridge is developing technology that addresses the paramount issues facing the nuclear industry. We invite you to track our progress, follow us on social media, and contact us with any questions you have.